Okay. We are about to start. Please just give us one more minute. We are just waiting to get a bit more of people. So just probably 10:05, we are going to start. Okay, please be patient. Okay, so it's already 10:05, so probably there will be more people who will be joining us a bit later, so it doesn't matter, they can join us later. So let me start today. So good morning, everyone. I'm Rafael Martinez. I'm a research fellow at the Lee Kuan Yew Center of Innovative Cities at SUTD. On behalf of the center, I would like to thank you for joining us for the webinar, Public Transport Through the Eyes of Service Quality, Technology, and a Fair Future, a case study of Santiago de Chile as an example of Latin American capital cities. Our speaker today is Dr. Jaime Sosa Parra. Dr. Sosa Parra, currently a postdoc researcher at the Three Revolutions Future Mobility Program at UC Davis, California, earned his PhD at the Transport Engineering and Logistics Department at Pontificia Universidad Católica de Chile. Before obtaining his degree, Dr. Sosa Parra was a visiting PhD student at Delft University of Technology in the Netherlands, the Department of Transportation and Planning. He was awarded the 2018 Lee Shipper Memorial Scholarship for Sustainable Transport and Energy Efficiency by the World Resources Institute Ross Center. In today's presentation, Dr. Sosa Parra will take us to a still rather uncharted territory for many researchers on urban issues in Southeast Asia, that is Latin America. Discussing the case of Santiago, Chile's most densely populated region, which concentrates more than 40% of the country's population, Dr. Sosa Parra's topic, public transport, grants us a point of entry from which to understand aspects related to transformation, innovation, and the urban in general in Latin America. After Dr. Sosa Parra's presentation, And time will be devoted to a question and answer session with the live audience. Throughout that conversation, online participants can submit their questions and comments through the Q&A panel. We will visit those topics in the second half of the session. So we look forward to an invigorating dialogue session with Dr. Sosa Parra. So without further ado, I turn the microphone over to Dr. Jaime Sosa Parra. Jaime.
Awesome. Thank you very much, Rafael. What a nice introduction. I've never heard, this is the first time I heard something like that about me. I like to start saying that I'm super honored and happy to be here and sharing with you some thoughts based, well, not only on my PhD experience, which I did studying the public transportation system in Santiago, but also some more general thoughts I have with regards to fair future or fair transportation, in a way, justice in a city, and also with some ideas about technology and how technology can, in a way, makes us pave the road to a different and better future. So as Rafa said at the beginning, I understand that not many of you that are part of this session are familiar with Santiago. So Santiago de Chile is the capital city of Chile, and it's around 5.6 million inhabitants, but basically is the most populated area in the entire country, and with a growing urban density with around 8.8 people per kilometer square, which is actually very similar when you compare to the numbers of Singapore, meaning in the both in the number of inhabitants and also in the population density, which is a bit lower for Singapore, but in the same order of magnitude. And it is in this city that we observe on an average, of course, and before the pandemic, around 10 million daily trips. So that's what we will say like the normal mobility in the city. And of these 10 million daily trips, around 55% are done in public transportation, which in the city is mostly run by metro. So most of these trips are done in this mode. And also we have 7 different bus operators. So something particular about Santiago is that there is a highly concentrated area which we call like the high income area, or the northeast corner of the city, okay, which is like this this area. Give me one sec. This area here, right, with this color in this figure. But basically in this area is where you get concentrated the higher proportion of the most affluent households in the city, most of the green areas and work opportunities, meaning almost all the offices of the most important companies that are located in Chile actually are located in this quarter of the city, if we can call it that way. And also most of the high quality urban furniture or amenities are located in this area. So there is a huge segregation, not only in terms of income, but also in terms of the amenities and facilities in the area. So as you can imagine, I mentioned that most of the offices are located in this place, but of course, most of the population lives in the other 3/4 of the city. And for sure, in the peripheral areas of Santiago, there is a huge concentration of people that lives in those areas, but needs to commute every day to some of these offices or some of these work locations, which are mostly concentrated in this northeast corner. So, as I mentioned some minutes ago, in such a city, which is, of course, it's not a mega city as I don't know, Sao Paulo or something like that, but it's a huge city in the number of inhabitants and also in length. And with such a number of public transportation trips, meaning over 5 million daily trips done in public transportation, it's not possible to run this public transportation system based on schedules, meaning knowing in advance at what time each bus is going to stop at each specific bus stop in the system. If you consider, for example, the number of bus stops is huge in Santiago. I don't remember the exact number, but it's a huge number of. It's impossible to operate a public transportation system of this magnitude, and considering the amount of the length of the trips in the city. So on the other possibility to operate a public transportation city system of these characteristics is operating by frequency, meaning instead of bus operators and metro as well, instead of providing exact departing times for each station, for each line, what they need to operate at a specific frequency at different time periods. Okay. So when like doing like a double click in this high income area on in the in the in the differences for different income groups, there's a huge difference between the lowest in quintile and the highest quintile in terms of just income. And this is taken from the work of a very close colleague, Ignacio Tisnao Aiken, where he showed that if you take into account not only the by accounting the model split for different modes for different quintiles, what we see is that there's the model split for cars is increased with income, meaning the higher income group mostly travels by car, and there is overall like a very similar level of public transportation for both all the other quintiles, but for the fifth. And if we consider the speed it takes to do a trip based doing it by car or by other modes, what we see is that the richest quintile makes 1.2 times more trips and an average speed of 1.6 times higher than the lowest income quintile. Meaning, in terms of very general, the richest quintile is also traveling at a higher speed, and they also travel more. And if we consider the amount of investment in different transportation modes, what we see, of course, there is a huge investment in metro, because in recent years, Santiago has been growing their metro network. But what we also see is that, on the contrary, the investment for buses is very limited, and the investment in urban highways is high, very high. So if we sum into this equation the average cost that takes for each of these different 5 quintiles, and we also consider the chart that I showed you in the previous slide, meaning the different modal splits, what we see is actually a huge disproportion between the mobility characteristics and also the mobility disparities between the lowest income group and the highest income group. So, for example, when we consider traveling by car, the lowest quintile must spend around 16.8 times more relative to their monthly income than the highest income group, meaning the highest income group does not have to spend that much of their household monthly income when they are traveling by car, but that amount is excessive when we consider the lowest quintile group. And if we consider actually the model split for these different quintiles, what we see is that the lowest quintile consumes a percentage of their monthly income, which is 4.7 times higher than the highest income group. And actually this goes up to 45.2%, according to, again, my colleague calculations. So what you see is that there is this huge disparity, again, in terms of how much time people dedicate to travel in the city, depending on their income, and also how much you spend of your monthly household income. So I don't know how, I don't think that you're very familiar with current politics, Chilean politics, right? But in October 2019, there was the Ministry of Transportation was trying to raise the fare of the public transportation system by 30 pesos, which was around 4% of the total fare. And in a way, there are many other causes for what happened next, but this was for sure one of the triggers that brought a significant social change of that in a way reflects something that didn't happen in Chile. I'm not gonna dedicate much time on this, but basically there's been this disparity I am presenting you in terms of transportation when you compare higher income and lower income groups. That's also something that was replicated in terms of access, the quality of education, university access, etc. So in this presentation, what I want to touch in the upcoming slides is basically my view on this disparity, what are the key factors that we need to address in order to improve or make a fair city in terms of transportation looking forward, of course, the upcoming years. And to do so, I just wanted, when I was preparing the presentation, I reminded this very general chart, right? Which I think is one of the very first ideas I got when I was doing my undergrad in transportation engineering, with this relation between this transportation system, the activity system, and the flows in a city or everywhere. So I'll dedicate some slides to the activity system, understanding the transportation as a derived demand, and I will dedicate propose some of the ideas that I think are relevant in this context. And then the most important half, I would say, of the presentation, I will focus on the transportation system, looking at the public transport level of service, which is most of the core of what I did on my PhD. And also, I will finish with some ideas of the importance of technology and how we can use technology or new ideas into improving in the end public transportation system and also and overall mobility as a whole for the residents in Santiago and also in other places in Latin America. So this idea of transportation as a derived demand, I took this definition from this Transport Futures Institute. Basically, this derived demand is an economic term that refers that the demand for transportation in the end is not for transportation itself, meaning people is not moving across the city because they want to move. In the end, they travel or they move because they want to do something else, because they want to get to visit a friend, they want to go to the doctor, they want to commute to work, or they want to go to the university or the school. So in the end, transportation by itself is not something that people really wants to do. It's just a mean to reach to achieve the goals that you have in your life, right? So as in the last bullet, people of course wants to commute to work, and we for sure have to focus on the location of the different offices and how these offices are served by the public transportation system. But also it's equally even important that we provide good access to other facilities or to other services in the city, right? So it's not only important the location of the office, but also the location of these other amenities in the city. So regarding commuting, what we've seen in the, I would say, recent decades, since the 80s, is that this activity center that we really like to call, right, meaning these downtown area or this huge place, this how is it called, like the city business district, right? The CBD has been moving towards the northeast of the city. Meaning, in the 80s, this CBD was located really in the center of the city in Santiago, and it has been moving in this direction, in the northeast direction, in recent decades. And this is part of a work of another one, very close friend, Gonzalo Soso Vecino. So, and if you recall what I presented some slides ago, this is actually the place where the higher income people live, and is actually the place with the higher amount of green areas, as I told, and so on. In a way, what's happening, and I don't have proofs, but I also don't have doubts about it, is that company managers in a way are trying to get their offices closer to their homes, meaning they live in this area and they also want that their offices are also close by, which has a huge impact because in the end, in this part of the city, we have the Andes Mountains. So basically, you cannot live like more to the east. There's like this geographical limitation. So basically, by moving this downtown, the CBD towards the northeast, what you're doing is that you're making it closer to the higher income people, but it's also making it farther away for the lower income people in the city. So this is not maybe a transportation thing, but the only way that I see that in terms of this activity system, right, which is where are located the destinations of the different residents of the city, is that we need some sort of a strong public policy to promote micro centers through the entire city, as I'm proposing in this very toy diagram, right? Meaning having not only one very big and concentrated CBD in a way in the Northeast area, but also promoting by different public policy schemes, maybe reducing taxes or some stuff, some ideas like that, to have CBDs in different areas of the city, so people do not have to continue traveling to the extreme northeast of the city to actually work. So on the other side, as I introduced in some slides ago, commuting is of course really important, but the access to other services such as green areas, for example, I have in this chart on the side, the location of the different green areas in the city, which as you can see, they are not much, but the biggest green areas are actually also concentrated in this northeast cone. But in the end, similarly to the locations of different offices, the location of different green areas or, of course, hospitals or urban facilities or urban amenities need also to be evenly distributed in the city, right? The huge concentration will only cause a higher disparity between lower and higher income people. But if we remember also that lower income people tends to travel more by public transportation or by walk or active modes, it's not only important to locate these facilities or amenities evenly distributed in the city, but also they need to be accessible. So if some I don't know, if a very beautiful park is very new and beautiful park is built in a lower income area of the city, but the public transportation system the public transportation route to reach that destination goes every 30 minutes, and it takes 45 minutes to reach a destination which is, I don't know, 4 kilometers away, then the benefit of this green area might vanish because this is not well connected to the places where residents live. So in that sense, the level of service offered but in public transportation is relevant and is key if you want to also guarantee the fair access to different services in the city. And this is me jumping also to the second topic of this presentation, which is on the level of service. And among many different things that I could talk about improving the level of service in transportation, I really want to focus on what I've done most of my research, which is on variability or reliability. So one idea I wanted to stress is that the experience in public transportation is variable by nature when you consider that it's a high frequency system, meaning you don't know when the next bus is going to arrive in advance. So it's variable by nature because at some point, when you compare it to traveling by car, when you travel by car, you just go outside your home and you enter the car and just start traveling. But when you travel by either either metro or even by buses, first you need to reach the station or the stop, right? And sometimes you're super lucky and the first and the bus arrives immediately with you, so you don't have to wait. But in some other times, you are super unlucky because you arrive and the bus have just departed from the stop. That means you have to wait an entire headway until the next vehicle. So, uh, in addition, so if this, I think this is very clear what I already said, but if, for example, your trip requires to transfer, this uncertainty in a way multiplies because you have to do this same phenomenon happens as many times as transfers you require or triplex you require. And not only that, but if the headways are not controlled by a centralized system, right, that controls the location of different buses or different trains as well, there is this phenomenon of vehicle bunching, which is, I don't know if you're paying attention to the video, but basically you have like huge gaps with no vehicle, and then suddenly 2 or 3 vehicles arrive at the same time. And finally, even if that's not enough, sometimes, at least in Santiago, this might happen, that there's a very same route might be served by vehicles that are super new or some vehicles that are way much older. So in that sense, right now there's a good progress in terms of service quality, in my opinion, and I think this is very clear because, for example, in terms of the metro lines, there are at least there are 2 new metro lines in Santiago, which has larger trains, and they also have no driver. I mean, they have a driver, but he's not driving the train. It's just for safety concerns in riding the train. And also there is a huge investment in new electric buses that has air conditioning and also Wi-Fi. So I took this from a newspaper that with 410,000 buses, electric buses, currently operational in Santiago, Chile, this city has the largest fleet in Latin America, and it has the largest of any city outside China in terms of the amount of buses, electric buses, sorry, operating in the city. But when we consider the operation, the story is a bit different. So something I also wanted to stress is that public transportation is also massive transportation. So you are not traveling by yourself. By nature, the nature of public transportation is also sharing the vehicle with others, because that's how you make it efficient, right, to travel. And what happens is that in rush hours, this is not like a disruption. This was more like what you will observe in a very typical morning rush hour in any metro station in the city. So this idea of regularity, of headway variability, right, which I introduced. Sorry, I thought I was going to mention something different. Sorry, my bad. So in terms of public transportation, the attributes that passengers would like to experience or what they want from a travel is they first of all they of course they want a fast travel. They want to reach their destination on time. They also of course nobody wants nobody likes to wait, so of course they want short waits as well. They want a travel which is comfortable for sure, and finally they want a travel which is reliable. So over the last decades, I would say that most of operators have been increasing the speed of their system. And why? Because increasing the speed has not only reduces the travel time and make the travel faster, but also by increasing the speed, you also increase the frequency because the time it takes a vehicle to do an entire cycle is lower when the vehicle is faster, and that increases the frequency because frequency in the end is just the number of vehicles divided by the cycle time. So faster vehicles also increase frequency, and by increasing frequency, you reduce the weights and also you increase the capacity in the end. So the travel is more comfortable. So overall, what I will say is that um, operators have been trying also always to make integration faster, and if they have some time, they will make it more reliable. Meaning the core is always what I've seen in different public transportation systems is that the goal is to increase the speed, and for sure, if it's possible to do something on um, on reliability, then they do it. But it's not like the, the essence. So, as I said, these public transportation systems in this very specific high frequency um, context behave like magnets, which is like this idea of vehicle bunching, which is super typical in any public transportation system which operates by frequency. And this operation with this regular headway operation, meaning if you have each pass every 5 minutes for saying something, is an unstable equilibrium, which means that at the slightest of any perturbation, what happens is that buses or trains also, if they are not controlled, they tend to travel together, as in the video. And this happens everywhere. This is not typical for undeveloped cities. This is you can observe this situation in London for sure, or in many other different transportation systems. So what are the effects of having an unregular operation for the passengers? So let's imagine we have a service which operates with an average headway of 5 minutes, meaning in the location of these blue arrows is where each bus is going to arrive. So as passengers do not know when the next vehicle is going to arrive in advance, they arrive randomly at the bus stop. So that's the assumption. And as the same amount of time happens between each bus, each arrival of each of these vehicles, they will be evenly distributed, meaning we will have like these 4 different buses with the more or less the similar number of passengers, right? And also all these tiny little people waited, I will say, the more or less the same amount of time, right? Let's on average 2.5 minutes. On the contrary, when we have a irregular operation, meaning instead of operating every 5 minutes, as in this example here, we have one bus at 2 minutes, then 8 minutes later, the other one, then 2 minutes, then 8 minutes later, then there will be a different amount of people waiting for each of these vehicles, right? Because the gaps have a larger or shorter depending on which one you're looking at. And that propagates downstream. So in the end, when you observe like the average occupancy in each of these vehicles, those that have the longer headways will be having like a higher passenger density inside, and those that were very close to the other vehicle will have like a very reduce passenger density. So this is super important. And why is that? Because if you calculate the average occupancy by only accounting the buses, meaning from the operator's point of view, you have, okay, I have a very full bus here, a very empty one, a very full one, a very empty one. Overall, if I do an average, is more or less all right. But if you actually ask the people, the passengers, most of them, I mean, all of these guys here and all of these tiny people here were traveling in the crowded bus. And only these 8 tiny person here, these tiny people, were traveling in the green one. So most of them were traveling in the crowded bus. Okay. So in the end, and the same happened for the waits, meaning most of the people were had to wait 8 minutes, and only a fraction of them had to wait only 2 minutes. So what happens when you have an irregular operation is that you have an increase in the expected waiting time, and also an increased expected passenger density, and also you increase the variability, because sometimes you will experience the empty bus and some others you will experience the crowd bus. So there is a variability in your experience as well. So not only that, but just to illustrate this point, let's imagine that we have this this perfectly regular system, but that which when we operate regularly, it operates with a passenger density of 3 passengers per square meter. Okay, and we already have this curve calibrated in one of my PhD works, which relates passenger density and satisfaction, meaning how satisfied they are with the trips. If you do have this irregular operation, meaning you have a lot of people traveling at 6 passengers per square meter, and a fraction of them traveling at a very almost an empty bus, they are all traveling seated. What you will see is that the operator actually will even see a satisfaction which is higher than what they already planned. Okay, so but if you consider the satisfaction experienced by passengers is way much lower. So in the end, of course, this is not the only reason, but we, in my research, what we propose is that this might be one of the reasons why sometimes operators on one side, they consider they're delivering a very good service, but when you ask the passengers, how is the service they're experiencing, they consider that the service is really bad. Because in this high frequency context, there is a huge variability or discrepancy between passenger experience and the operator point of view. So just to sum up, these irregular headways have different negative effects. So they increase the system cost. They increase also the average waiting time. It deteriorates the average comfort, promotes variation for sure, and also reduces user satisfaction. So what I would like to dedicate the last 5 minutes, I would say, of this presentation is how technology might facilitate a more regular and a more speedy public transportation operation, because it's clear that this irregularity worsens passengers' accessibility to all the different features and amenities of a city. So metro services have some significant advantages because of their nature, meaning they are going underground, they have segregated infrastructure, they operate centralized. So actually, most of the things I will say are focused on bus operation. So one of them, of course, is dedicated infrastructure. Having a segregated lane increases the level of service, improves the level of service experienced by passengers a lot. And also, for example, this is that's not totally related with infrastructure, sorry, with technology, but traffic signal priority, of course, it is related with technology. And in this area of connected vehicles, giving it priority to buses when there is congestion will, in a way, mimic the segregated lane operation where there is not it's not possible to have these segregated lanes. It's not possible to have segregated lanes in all the streets of the city because you're sharing the streets with other modes, right? So, but having a way to prioritize the operation of buses, in a way, might mimic, as I said, the convenience of having segregated infrastructure. Most importantly, and looking forward more on the futuristic side, and actually, but this is not futuristic anymore, I would say, we have all this idea of CAVs, or connected and automated or autonomous vehicles, right? And in that sense, public transportation has been autonomous in many places since decades ago. So I guess that many of you have carried an international flight, right? And you have visited maybe a very big international airport, and with different terminals. And in these terminals, they are usually connected by these shuttles that are run automatically, right? So there is no driver of any kind, but they are operated centrally by the system, right? By the centralized system. And also, we observe we have modern metro lines in Santiago. We have two of them. The two newer metro lines are right now autonomous. Just they have drivers, but these drivers are not driving. They are just there because if there is an energy shut off or stuff like that. So they are just for safety concerns and not because you need someone to drive. And of course, on the other side, for private vehicles, we observed that this idea of autonomous vehicles made by Google or other companies are every day more common, meaning some years ago they were very incipient or very new, but every day is more common to hear these advances on different automated vehicles. But how about buses? What's happening with buses, right? So when you, on the contrary, when you think about metro, one may think that metro make it very easy to conceive this system as connected and autonomous because, as I said, they are segregated, they are operating in a rail. So it's like the next step just to have them operating in a synchronized way, right? But it seems all the contrary for buses, right? Because as they are sharing the space with other modes, it seems to be it might be harder to run automatically and also connected, right, between different buses. So just to sum up, what I think would be why I think this idea of connected and autonomous vehicles would be a good idea for buses. And in the first step to reach that goal, in my opinion, would be to first do this in segregated corridor because you have a more controlled environment. That will have like huge benefits for bus riders or bus passengers. It will improve safety for sure, meaning you will remove the human component of the driving. So, and by doing that, you will improve safety, like by definition. By being connected, you will also, coming back to this idea of traffic lights priority, traffic signal priority, the location of the buses might be also be connected with the traffic signal times, right? So in the end, the operation for buses will be more speedy. Eco driving for sure, meaning the driving will be as more efficient as possible. They will enable a synchronized operation, meaning transfer will be facilitated, and also coming back to what I mentioned, to all I mentioned on headway regularity, by having a connected fleet of different buses, you will also achieve a perfectly regular headways, meaning you will control the location of buses in such a way that passengers are both experiencing the lowest waiting time possible and also the most comfortable experience. So as how I see, and this is very personal, but I think that this centralized and coordinated control in terms of this technology might provide, in a way, these rails that buses need, right? These, in essence, I see this idea of CAVs applied to public transportation in the form of buses as a way to facilitate the operation of buses, replicating or mimicking the the operation offered and the level of service offered by Metro, which is superior. So yeah, I took way much longer than I expected, but I think it was I touched a lot of topics that I hope that have raised some I don't know interesting ideas that we can dedicate some time to talk on. And again, thanks for the invitation, Rafael, and I would like to continue the conversation.
Thank you very much, Jaime. It was very interesting time for the Q&A. So we have a question, I think, from Winston, my colleague Winston. Winston, would you like to ask your question, or let me see? I think it's on
Let me.
Hello.
I don't know if they're reading.
Yeah.
Yes, I can.
Thank you so much for the presentation on Santiago, and I learned a lot about the transport situation in Santiago. So I think in your talk, you mentioned that inequality and justice is particularly important for Santiago moving forward. And you also mentioned that, for example, the bus system and how technology can help to improve that situation as well. So my question is, so is there a roadmap in your mind of, like, for example, what needs to be done in the short term? Like, because of like existing constraints, I can imagine like the city is already very congested. So my question is, and I know it's a hard question, but is there like a roadmap that you think like needs to be done to achieve the intended outcomes? Yeah, thank you.
So, yeah, I don't think there is a roadmap, to be honest. I think there are good practices or good ideas that need to be promoted or encouraged also by governments, right? Especially under these circumstances of huge disparities in the city. So maybe I wasn't clear enough when I was doing the presentation of how to connect the different dots, right? Meaning how connecting this idea introduced of this high inequality and how important it is to have the public transportation system to use it as a tool to reduce this inequality. So far in what I've done in my research or what I've seen is that there is still this idea of I will only focus on headway regularity in the end. This idea of achieving regular headways, is not being neglected because that would be too harsh to say, but has not given the importance that, in my opinion, should have. So, by something that is possible to do right now, and some operators do it on a daily basis, is to control not only the headway, meaning how regular headways are between different buses, but also the dispatch. Because what we've seen sometimes is that they don't even do any effort to dispatch the vehicles in a regular way. They are even doing it irregularly at the very beginning. So what can you expect for the downstream operation? It will be heavily bunched after a few kilometers. So in addition to, of course, the promoting or having a specialized infrastructure for buses, I will argue that maybe I'm biased because I dedicated too much time to research headway regularity, right? But I will argue that this is one of the topics that has been neglected, and improving it has positive effects on many different sides, in many different areas. So by improving regularity, having this control system that tells drivers, I thought I had a slide on that, but maybe I skipped that. having this controlled system that tell drivers slow down, go faster, um, to achieve these regular headways, uh, improves a lot the level of service experience by bus passengers. Not only on the reduce of the waitings, but also on the reduce on the passenger density, so you have a more comfortable experience. Um, having we also explore, I didn't have enough time to touch everything, right? But we also explore a different paper, the different impacts that a regular operation or have. And also, it also speed up the operation because you reduces the chance that a bus, when the bus arrives to a bus stop, having a regular operation, it reduces the chance that the bus is crowded with buses. Which sometimes buses need to wait until the buses that were before uh, clear the bus stop. So there's this additional, how can we call it? Like it's an additional delay in the transport in the bus operation, in that you can get it reduced by having a more regular operation. And it might sound that by doing this, meaning by promoting segregated infrastructure for buses and also promoting a more regular and more a higher level of service for buses, that's only focusing on buses. But if you think about it, uh, right now, a lot of people is not using buses because of this, and they use in an excessive way metro, right? And that's why you also see a lot of people traveling by metro instead of traveling by bus. So in my view, by also improving the level of service offered by buses, you will also improve by doing nothing the level of service experienced by people riding the metro, because some people will find it now more convenient to travel by bus, because many times it is more convenient to travel by bus. And more people will do that. And by doing that, you will reduce the number of passengers traveling by metro during the rush hour. So you will also improve the level of service experienced by metro. So yeah, just to finish, and maybe I went to the branches, but to round up this question, I think that by improving the level of service of buses, you will also improve the level of service offered um, for the public transportation system as a whole. And then provided with the other public policy, right, on having a more evenly distributed activities or desired destinations in the city, I think you will not directly achieve that, but you will. I think you will go in the correct direction of promoting a more fair city in terms of mobility.
Very good. If I may, we have another question. Thank you very much, Winston, for your question. So let's move to the next question from my colleague, Frederick Hanson. Frederick is asking, how much do housing prices and living costs differ between the Northeast and the rest of Santiago? This is a quite interesting question as well.
Yeah, I'm sorry I don't have like the numbers, but I've been living, well, until some weeks ago, I was living my entire life in Santiago, so I am familiar with the city, and I might have some figures. So, for sure, it's way much higher, like housing costs in the Northeast area. And sorry, I don't have like the exact number. I am not able to say 10 times higher or I don't know, 5 times higher. But something that these questions brings me also back in terms of, which is related with housing costs, is this effect of gentrification. So what we have observed in recent years, especially with metro lines. So this is not something that happens with segregated lines for buses, but for metro, this is huge. That when you create these new lines, the surrounding housing, right? The housing which is closer to the different metro stations start to get an increased amount of, an increased price in housing. And this also translates into rent costs for people that is not allowed sorry, is not able to pay for that. So a lot of people in Santiago do not own their place they live, so they have to pay rent, and that's especially the case for lower income people. So if they happen to live in a place where a new metro line is built, the gentrification, what will the benefits, meaning, of course, it rises the property value, right? Because now it's better connected, and a metro line promotes the location of commerce, right? Um, but those benefits go to the owner of the property and not to the one living in the place. So that's a huge another story, that the negative effects of this gentrification that have maybe in the end what happens is that people that might be may perceive the benefits, in the end they have to move to a different place of the city because they are not able to pay the new rent, for example. So yeah, that's a bit out of my scope of research. So I'm not very on urban planning. So I'm sorry, I don't have like the exact number of how different the housing costs are. I can for sure say is maybe between 5 or 10 times, but that would be my guess. But take it with a grain of salt. But yeah, thanks for the question.
Thank you very much, Jaime. I think, do we have another question from the audience? We still have 2 more minutes. Well, if not, I would like just to ask one last question in the remaining minutes. Jaime, to what extent COVID-19 has presented like an opportunity to Santiago to redevelop or to I don't know, to reformulate its solutions or problems regarding public transport? Because clearly COVID-19 has changed everywhere, and I don't think Santiago is an exception. So what do you think about this? Is it an opportunity, or has made problems more acute?
Just to come up with the previous question, I got a message from Juan Carlos, who is also attending the webinar. So he sent me some figures, and between the higher income and the lower income areas of the city, you will see an average of 3 times difference. Okay, so I was a bit on the higher side, so it's around 3 times, okay, between the higher and the lower income area. So on the COVID, I don't think, this is very my opinion, Rafa. So I don't think it has brought so far many opportunities. I think there is one, but I don't think it has been achieved in a correct way, or in any way. But for sure, it has made the problems more acute, right? Why is that? Because I have also seen this in the analysis I'm conducting now in California, in the US, that of course we see a huge increase in telecommuting, right? People working from home right now, meaning we are doing this presentation from the entire opposite side of the world with you guys in Singapore. And as this, I've been having many different meetings in different places of the US, and also many of my colleagues right now are living in many different countries. So there's for sure an increase in telecommuting, but what we've seen in Santiago, and I think this is the case, of course I don't have evidence, but I think this is the case almost everywhere, that this is more concentrated on higher income, highly educated, white collar workers, right? So if you happen to have a management position, then the chances that during the pandemic you've been working from your home are higher. On the contrary, for people that's on the lower income segment of the population that have, I don't know, a job which is related with services, they are in charge of cleaning, or they they are working in a store, right? They need in a grocery store. I don't know. You can come up with many other different examples that I can't do myself right now. But most of them are not able to telecommute at all because the nature of their job is not telecommutable in a way, if that word exists. And thus, they have been required to travel these huge distances on public transportation, wearing face masks with all the concerns about getting the disease. Right now, after 1 year of this pandemic, I think we have a more uh, clearer idea of the risks about regarding traveling by public transportation. We now know that if it is well ventilated, if you're using your face mask, the chances of getting the infection, of course, they are not zero, they are never zero, whatever you do, but they are not as high as you might think at the very beginning of the pandemic. And at that point, of course, it was absolute chaos for people, and especially for lower income people, meaning they were, in a way, they are not forced, but they had to go to their jobs afraid because they didn't want to get this unknown disease with very limited information. They are also less educated, sadly, and they might not get the pieces of information communicated by different authorities. So it's a huge problem. It's a very big problem for lower income people, what the pandemic has caused to them. Not only, and also we need to think that this will happen for people that is still commuting, meaning that they didn't lose their jobs, because a lot of people lose their jobs because of the pandemic, right? Because of all the economic crisis that the pandemic raised. So yeah, I think there are opportunities, Rafa. I'm not that pessimistic. More on the opportunity side, I will say, I will think that the telecommuting has come to stay in, I would say, everywhere, at least at maybe not full time, but at least part time. And this reduce in the number of trips might be taken as an opportunity to redirect the fleet to serve certain areas with a higher frequency, maybe. Um, I don't know. I think there's an opportunity, but it's still too early to to realize if it will be something more permanent or not. Yeah, for sure it have worsened the differences between the higher income and the lower income people.
Very good. Well, I think we're done for today. It's already 1 hour. And so thank you, Jaime, for answering those questions and for the great presentation. It was a pleasure to have you with us. And so this concludes the webinar. Thank you all for attending. We hope you have learned and enjoyed this presentation as well. So thank you very much. Thank you very much, Jaime, and see you around. Thank you.
Bye. Bye. Again, thank you very much, Rafa. I really enjoyed the opportunity.
Thank you very much, Jaime. So bye-bye.
Bye.